All right, ladies and gentlemen, I'd like to start today's lesson by going over some of the issues that I saw with practice A from section 4.2. All of your worksheets are being sent to my house. I'm grading them. It gives me time to really look over them and pick out the questions that you're having and things you're not understanding. You're being graded based off of your effort, as usual. So it's not like if you miss a question, you're going to lose points. Unless, of course, there are certain things happening. Anyways, number 2, EF. So because we're looking at this triangle being congruent to this triangle, we need the parts that are also congruent. So EF is the first 2 letters, which makes it congruent to the first 2 letters of the second triangle. So that's congruent to OP. Number 3, angle P is congruent to angle F. Number 4, this is where I got confused because I saw a lot of answers that said angle G. Now when I look at this, angle G congruent to angle G, well, that's true, but it's not going to make sense with what we're talking about. We're making this angle congruent to some angle from this triangle, which would make it angle Q. Angle G is not correct. It's got to be angle Q. So when I looked at it, I thought about it, and I said, why would everyone have angle G written down? So they're either copying off each other or coming up with another way of getting it. So I checked the answer key, and they incorrectly put angle G for number 4. Those of you who wrote angle G have lost half credit on the homework assignment. I'm paying attention to the answer keys. I'm checking to make sure that you are not just copying. If you happen to find the answer key, great for you. But when your test comes around, you're going to get crushed. I've seen it numerous times already this year. I've seen it in the past. I'll probably see it in the future. You're going to get crushed on your test if you're just copying answer keys and not paying attention to what is going on the actual homework assignment. There's no reason that anybody should have written angle G down unless you are copying off of either the answer key or someone in your class. Either way, it's the reason that you lost your points. I'm done with my preaching now. On to number 5. Measure of angle Q, or angle O, is this angle here, which relates to angle E. Now, anytime you see an equal sign, it means that it wants the actual measurement. That's 110 degrees. Same thing here. QO equals, well, it's congruent to EG, which means it equals 7 kilometers. In triangle GFE, you have to write it in the same order. So G was congruent to Q, not G, remember? So it's triangle QPO. The other way to do it would be to notice that it went backwards. GFE, so QPO. All right, on to bigger and better things. 4-5, prove triangles congruent by angle, side, angle, and angle, angle, side. Postulate 21. Once again, on your test, whenever I ask you for this, don't write postulate 21. Write ASA, or angle, side, angle. If 2 angles in the included side of one triangle are congruent to 2 angles in the included side of another triangle, then the 2 triangles are congruent. You're going to want to pause the video so that you can write that down. Now, the important thing to notice here is it says included side. The included side means that it has to be in between the 2 angles. So here we have angle A and angle C. The included side has to be in between those. The easiest way to check that is to check the sides that they're touching. They both touch this side, so it's the included side, or the side that's between them. So this says that if we're given an angle with a side between it and the other angle, So angle A congruent to angle D, side AC congruent to DF, and angle C congruent to angle F, then we can say that the two triangles are congruent by angle side angle. Just to get some practice on this, well, first let's look at theorem 4.6, which is the angle side congruence theorem. Once again, you're going to want to pause so you can write it down. If two angles in a non-included side of one triangle are congruent to two angles in the corresponding non-included side of a second triangle, then the two triangles are congruent. It says that if we have triangle A, or angle A, congruent to angle D, angle C, congruent to angle F, and this side over here that's not in between them, see how it's not in between the two angles? It's up on the side here. If those are also congruent, BC congruent to EF, then we can say that the two triangles are congruent by angle side. So far we have side, 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 angle, side. I'm going to write it off to on the side here, or up top here. Side, 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 angle, side, angle, side, angle, angle, side, and HL. Remember, you can only use HL with right triangles. The rest of them can be used with everything else, or any type of triangle. Knowing that you have all those, after we're done with this section, we're going to take a day to have an additional assignment so that you can really practice your use of all of those different things, all those different congruence proofs. Okay. Now let's practice and see if we can prove that these triangles are congruent with the information given in the diagram. Now, this does not necessarily mean that it's going to be angle side angle or angle side. Okay? Letter A, we have this angle congruent to this angle congruent to this one, and from the middle we know that those are vertical angles, which means that those are congruent to each other. But do we have an angle postulate? That answer would be no. Do we know any information about any of these sides? That information would also be no. So the answer would be no. You cannot prove that they're congruent. Look at B. We have an angle and a side of this triangle and an angle and a side of this triangle. Now in the middle, those are vertical angles, which says that those are congruent. Now you have angle, an included side, and another angle. Angle, side, angle. Whenever you're writing these down like angle, side, angle, you have to make sure that you're talking about the same triangle. I've seen some people look at it this way, like, oh, I have angle, angle, and a side. You can't jump from one triangle to the next. It has to be on the same one. For C, we have an angle congruent to another angle, so angle. We have this angle congruent to this one, and then we have this side. So you have angle, another angle, and a non-included side. That is angle, side. Let's look at number 1 down here. So the first thing that we're going to think is, because it's a right triangle, that we can use hypotenuse leg, right? So we have a leg here and a leg here, but we don't know what the hypotenuse is. So hypotenuse leg isn't going to work. What we do have, though, is vertical angles inside of here. So we know this angle is congruent to this angle. This side is congruent to this side. Now you have a right angle and a right angle. So those two are also congruent. Because we have a whole theorem about right angles all have to be congruent to each other. So now if I look at this triangle alone, I kind of have to forget about this one. I have angle, an included side, and an angle, which tells me it's an ASA. Number 2, this angle is congruent to this one. This angle is congruent to this one. And then I have this side congruent to this one. Now if I forget about this triangle, and just look at this one, I have an angle, angle, side. So it's AAS. Now some people would say I could easily just do angle, side, angle. But that's not the included side. That side is not in between these two. It's not touching both of these angles. So you cannot use it as angle, side, angle. It has to be angle, angle, side. Number 3, you have an angle, a side, and a side. That would give us side, side, angle. You thought I was going to say it the other way, like this one. But it's side, side, angle. We don't have a side, side, angle congruence proof. And that's because you can't prove that two triangles are congruent to each other using side, side, angle, or ASS. If you try to use ASS, that's what you are, because it does not work, ever. So remember it that way. If you come up with ASS, it's not right. Okay, write down what we're given and what we have to prove, and then we will go through the statements and reasons. Okay, you're given angle PQS is congruent to angle RQS. The first thing I would do is make sure that's marked on my figure. So I know that angle PQS is congruent to angle RQS, and that's marked. But I have to write it as a statement. Angle PQS is congruent to angle RQS. The reason is given. Number 2, you might not necessarily have to write this as a separate step, but angle QSP is congruent to angle QSR. That is also given. So if you wanted to write that all under step 1, I would be perfectly fine with it. I would not take points off. Okay, so basically we have an angle there, angle here, and angle here. Now, is there anything else we know about these two triangles? Is PQ congruent to QR? Well, we would hope they were, but we don't have enough proof to say that they are. It doesn't tell us anything about PQ and QR. What about PS and SR? Same thing. We don't know anything about them. What about QS and QS? Because it's in the middle, and it's part of both triangles, you know that it's congruent to itself. So you know that QS is congruent. It's not an angle, that's a side. QS is congruent to QS. And anytime anything is congruent to itself, you know that that is the reflexive property. Now when we look at this, I see an angle, a side, and an angle. So I can say that the triangles are congruent to each other. So step 4 would be triangle PQS is congruent to triangle RQS, and the reason is angle, side, angle. And that's all you need for your proof. They're congruent to each other by angle, side, angle. Oops. Go ahead and write down the next one. We have OMN congruent to ONM. And then I'll just write it under the same step this time. LMO congruent to JNO. And the reason for both of those is that it is given. Sometimes you might feel the need to separate these triangles out and to redraw them yourself. Now my redraw isn't going to be perfect. But I see J and M. I don't want to drag this over. And you see how separating these out might actually help you. And then it's L, M, N. Okay, so far we know OMN which is the same as JMN. See that? Because OMN starts right there. JMN goes that direction as well. Is congruent to ONM. So that angle is congruent to that one. Then we know LMO or LMJ is congruent to JNO. Oh, that's not what I thought it was. This is congruent to, sorry, JNO is congruent to LMO. So really, separating these out isn't going to do us any good because it has to be part of that bigger figure. There will be times when separating it out helps. Okay, anyways, step 2. There's something I notice about both of these big triangles because we're trying to prove that MJN, which is the big triangle, is congruent to this big triangle here. NLM. So the one thing that I notice is that if I look at my dots, JNM and LMN both share the same two dots, right? Between N and M. And so now I know that NM is congruent to NM. And the reason for that is the reflexive property. Okay, so I have this side congruent to itself, have this angle congruent to this one. Now, if we're looking at the big triangles, have an angle, a side, for this triangle. And so if I look out beyond that, I could either say that L is congruent to J, which would make me able to use angle, angle, side. But we don't know anything about L and J. And so I have to come back to the inside, and maybe angle M is congruent to this big angle N. And here you see we have some congruence markings for those. So that's the one that we're going to go with. Step 3 is that we can say LMO plus, so let me draw it out, this angle LMO plus OMN is congruent to angle LMN, which is this whole angle. And the reason for that is the angle addition postulate. That said that we can add two angles together that are connected to equal the bigger angle. Step 4 is going to be very similar. We're going to be able to say L or J and O plus angle O and M is congruent to angle J and M. And that's angle addition postulate. But you see, we don't have the same angles inside of here. So we know that if we took this angle, which is congruent to this angle, and added it to this angle, which is congruent to this angle, then they equal the same thing, or are congruent to the same thing. But that does not necessarily make the two congruent yet. So we got to move on to a step 5. Now, if we look at step 5 says that we can then start substituting values in, because we know that angle ONM is congruent to angle OMN, and angle LMO is congruent to angle LNO. I can substitute those in. So angle LNO plus angle instead of OMN, I'm going to plug my ONM in. Is congruent to angle LMN. And that's going to be substitution. So this should be a JNO here, because we know LMO is congruent to JNO. Then for 6, now you can conclude that angle LMN is congruent to angle JNM. That's because this is the same as this, and this is congruent to this, is also congruent to that. So you can either say substitution or the transitive property. Either one will work. Now for our final step, we know that JNM, this angle JNM, is congruent to LMN. We know that the small angle inside, angle NMJ, is congruent to angle LNM. So we have an angle. We have the side in between them. So it's going to be angle side angle, and you can say triangle MJN is congruent to triangle NLM. And your reason is angle side angle. I'm sure you have some questions on that. Rewatch the proof again. See if you can make the connections. It's important to realize that triangle congruence proofs can be this simple, or they could be this complicated. What I put on the test, well, that shows me, or that'll be decided by how much you know. For instance, if you happen to be coming up with the same answers as all of the answers on the answer key, word for word, then I know that I can put a more complicated proof like this one on there. You'll be perfectly fine to handle it. Pay attention to what you're doing. Pay attention to the lessons. Actually do your homework assignments. All right. Good luck on the homework. Like I said, after this section, we will actually take a time out from learning new material to kind of put all this together into triangle proofs and into proof style questions before we move on to the next topic. Next topic is just more of the same. Different way of going about it.